Hello and good morning to Chapter 9, Section 3, Geometric Sequences and Series. You will need to pause the video at this time to copy down this information. Now we'll use that information to go over a few examples. First, we're going to find the geometric sequence. For each geometric sequence below, we need to find the common ratio. Well, to find the common ratio, you take the second term and divide it by the first term. And that's going to be equal to 3. And then you take the third term, divide it by the second term, that's 3. You take the fourth term, divide it by the third term, and that's 3. And you take the fifth term and divide it by the fourth term, and that's 3. You can see that they're all 3's, so that means that my common ratio, R, equals 3. Okay, we do the same thing with our next problem, except for we're having to work with fractions, so that's 1 over 16 divided by negative 1 over 4. Well, we flip this over, that makes that negative 4 over 1 that we multiply the top and the bottom by, and we get negative 4 over 16, or negative 1/4. So we know for our problem here, the common ratio is going to be equal to negative 1/4. At this time, pause the video and copy this information down. For our first example, we want to write the first 5 terms of the geometric sequence whose first term is a sub 1 equals 2, and whose common ratio is r to the 4th. Is r equals 4. So all we do is write it out. That's going to be 2 times 4 to the 0. The next term is going to be 2 times 4 to the first. The next one's going to be 2 times 4 to the second. Next one's going to be 2 times 4 to the third. And then the last one's going to be 2 times 4 to the fourth, which comes out to be 2, 8, 32, 128, and 512. Okay, our next example, find the 9th term of the geometric sequence whose first term is 4 and whose common ratio is 1/2. Well, we have our formula from the previous slide of a sub n equals a sub 1 times r to the n minus 1. Well, we're looking for the 9th term, so that's a sub 9 equals 4 times 1/2, my common ratio, raised to the n minus 1. And our n is 9, so that's 9 minus 1. And that's going to be equal to 1 over 64. So there's our 9th term. Okay, let's try another one. Let's look at our 10th term. Well, first thing we need to do is we know what a sub 1 is. A sub 1 is 6, but we need r, and r is going to be equal to the second term, negative 2, divided by the first term, 6, which is negative 1/3. Okay, now we have our a sub 1 and we have our r. We're ready to plug into our formula. So that's a sub 10 equals 6 times negative 1/3 raised to the 10 minus 1. Okay, so we plug that into our calculator, and a sub 10 equals negative 2 over 6,561. Okay? Now on to our last one. The second term of a geometric sequence is negative 18, and the fifth is 2/3. Find the sixth term. Well, there's a few things we need to find. We need to find r, and we need to find the first term. So we know that a sub 2 is equal to negative 18, and the fifth term, a sub 5, equals 2/3. Okay, well, we can plug into our formula. This time our it's going to be a sub 5 is 2/3 equals, and it's not a sub 1 this time, we're using a sub 2, so that's negative 18, and that's going to be r, and since our a sub n was 5 and our a sub 1 is 2, it's going to be 5 minus 2. Okay, I'm going to divide both sides by negative 18, and that gives me negative 1 over 27, which is equal to r cubed. So that means that r equals negative 1/3 when I take the cubic root of both sides. Okay, now that I have that, I'm ready to find my sixth term. Well, excuse me, need to find my first term first. And a sub 1 is going to be equal to, now since I'm going backwards, my common ratio is going to be the reciprocal of what I've just saw, so I'm going to take negative 18 and multiply it by negative 3. So a sub 1 equals 54. So now I can plug in a sub 6 equals 54 times negative 1/3 to the 6 minus 1. Okay, we plug in that into the calculator, and a sub 6 equals negative 2/9. Okay, you'll need to pause the video to copy the information down, and then we'll go over the example. Okay, now we're ready to do our example. We've got our formula, and all we need to do is plug into our formula. So we've got a sub 1 times 1 minus r to the n over 1 minus r. Okay, if we look at our problem, we see that we get r from right here. That's my r. My a sub 1 is going to be plugging into that, so I'm looking for a sub 1. That's equal to 2 to the 1 minus 1, which is equal to 1. Okay, so now I can plug everything in. I have 1 times 1 minus 2 to the n, and the n is my biggest number, which is 7, all over 1 minus 2. And that's going to be equal to 127. Okay, one more topic to cover, the sum of an infinite geometric series. Okay, pause the video at this time so you can copy this information down, and we'll get directly to the examples. Okay, time for our first example. We want to find the sum of 5 times 1/2 to the n power from 0 to infinity. Well, we use our formula, which is s equals a sub 1 over 1 minus r. Okay, so we plug in everything we know. Our a sub 1 is going to be coming from right here, and our r comes from here. So s equals 5 over 1 minus 1/2. Okay, we plug that into our calculator and we get 10. So our sum for that is 10. Okay, now let's look at our next problem. It is just the same type of problem that the previous one was, but it's written in a different form. So we're going to have to find some things. We're going to have to find r so we can find our s. We know what a sub 1 is. A sub 1 is 5. Our r is going to be equal to, just like we've been finding r, second term divided by the first term, which is going to be equal to 0.5. Okay, so we get s equals 5 over 1 minus 0.5, just plugging directly into our formula, and we get 10. Okay, that does it for Chapter 9, Section 3. Hope you enjoyed the lesson, and see you in class.